A NEET 2020 question from coordination compounds. Which of the following are paramagnetic? 5 compounds are given. In each of these compounds, you can see that nickel is the central metal atom. In each of them, all 5. Then we have ligands, chlorine, chloride, then carbonyl, then cyanide, water, and triphenyl phosphine. So of these ligands, we know chloride and water are weak field ligands. The others, CO, CN, PPH3, they are strong field ligands. So strong field ligands, as you know, will make the electrons pair up. Now we are asked to find which of the following are paramagnetic. Paramagnetic means there has to be unpaired electrons. So let us see how we can do it. Since nickel is the central metal atom, atomic number of nickel is 28. We need to find the electronic configuration argon, then 3d8 4s2. That is the electronic configuration of nickel. We can represent it, outer electronic configuration can be represented as 3d8 and 4s2. 4p vacant. One, 2, 3, 4, 5, 6, 7, 8 electrons, and here you have 2 electrons. Now let us start with the first compound, that is NiCl4 2-. In the case of NiCl4 2-, what is the oxidation number of nickel that we need to find? Let X be the oxidation number of nickel. There are 4 chloride ions. So X plus minus 1 is the oxidation number of chlorine into 4 equal to overall charge of minus 2. So X minus 4 equals minus 2. X equals this minus 2, and this minus 4 when it goes to the opposite side will become plus 4. That will give you plus 2. So nickel is in its plus 2 oxidation state. That is Ni2+. Now the electronic configuration will become, here we were having 3d8 4s2. So if it is Ni2+, 2 electrons from the outermost orbit from 4s will go away. Now nickel will be having 4s is vacant, 4p is vacant. Okay. Now the 3d8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Now how many electrons are there? Unpaired electrons. 2 unpaired electrons are there. Since chloride ions or chlorine ligand is not a strong field, it's a weak field ligand, it will not make these electrons pair up. So that means NiCl4 2- will be paramagnetic. That will be paramagnetic because there are unpaired electrons. And these 4 positions, 4s and the 3, 4p, will be occupied by the chlorine or chloride ligands. So it will be having an sp3 hybridization or sp3 hybridization geometry or sp3. Now the next one, that is NiCO4. We know CO is a neutral molecule, so it is having 0 oxidation state, and nickel will also be having 0 oxidation state. That will mean nickel will have the electronic configuration of this will be the, since nickel is having 0 oxidation state, this will be the electronic configuration of Ni. Now what will happen? 4 carbonyl ligands are coming. When the carbonyl ligands come, they are strong field ligands. They will make these 4s electrons go to the 3d8. That is, they will make these electrons pair up. That will mean it will have a fully occupied 3d orbital. It will be having 3d10 and 4s and 4p will be vacant. So let us see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those 2 electrons from the 4s bonded or paired up with the 3d8. Now 4s and 4p are vacant. So the 4 carbonyl ligands can come in, and this will be having sp3 hybridization. And are there any unpaired electrons? No unpaired electrons. So this complex will be diamagnetic. Now next one is NiCN4 2 minus. So NiCN 4 times 2 minus. Let X be the oxidation number of nickel here. Cn is having -1 oxidation state. -1 into 4 equal to overall charge of -2. So X minus 4 equals -2. X is equal to -2, and this -4 will become +4. So it will become +2. Nickel is having +2 oxidation state in NiCN4 2 minus. So that is Ni2 plus. So that will be having the electronic configuration C4. The outermost 2 electrons will be gone in the case of Ni2 plus. So it will be left with 3d8. So we can put it like this. (3d8). 3d8. Because the 4s electrons are gone. Now here also Cn is a strong field ligand. That will make these electrons pair up. Now then what will happen? This electron will pair up, and so this will be the situation. So 1d orbital is there. So 3d8 is there. Then d, how many ligands are there? 4 ligands. So this d, 1s and 2 p's will be occupied. This is the 4s and 4p. This is the 3d. Here also dsp2 hybridization. Any unpaired electrons? No unpaired electrons. So NiCN4 2 minus will be diamagnetic. Next one is NiH2O 6 times. Here also water molecule is having 0 oxidation state because it is a neutral molecule. But then nickel will have this overall charge of Ni2 plus. Ni will be in its +2 oxidation state. what will happen? The 4s electrons will be gone again, because 3d 8 4s2, when it is in its +2 oxidation state, these 2 electrons will be gone. It will be left with 3d 8. Okay, and water is a weak field ligand, so it will not pair up the electrons. But how many water molecules are there? There are 6 water molecules, so it will need more space. Here there are only 4 blocks, 1 2 3 4, so it will need more. 4d will be here. So 6, 1 2 3 4 5 6. So it will be a sp3d2 hybridization. sp3d2 hybridization, and there are unpaired electrons. So NiH2O6 times will be paramagnetic due to the presence of these 2 unpaired electrons, and the hybridization will be sp3d2. S, then 3 p's from the 4p and 2 d's from the 4d. sp3d2 hybridization. Next one is NiPPH, that is triphenylphosphine or triphenylphosphane. This is a neutral molecule, 0 oxidation state. So nickel will also be having 0 oxidation state here. That means nickel is having its original configuration. 3d8 4s2 will be the configuration. But this PPH3 is a strong field ligand. It will make these 4s electrons go to the 3d8. So that means there will be pairing up of the electrons, and 4s will become vacant. So the configuration will be like this much is the 3d8. Then 2 of the 4s electrons will also come in here, and it will be fully filled. So this will be 3d10. And how many PPH3 or triphenylphosphane are coming? 4. So they will occupy these positions, 1 2 3 4. So this will be having sp3 hybridization. And are there any unpaired electrons? No unpaired electrons. So this will be diamagnetic. So PPH3, Cn and CO, they are strong field ligands, whereas water and Cl are weak field ligands. Now let us look at the question. Which of the following are paramagnetic? And the answers given are A and D only. Which one is A? NiCl4 2 minus, that is paramagnetic. And D is paramagnetic. And all the others are diamagnetic. That is what we have got. So only A and D only. So the first option is the correct choice. And we have seen their geometries also, or hybridization also. You can get the geometry from the hybridization.